kinematics, we analysed acceleration without asking what caused it. In this week's lesson, we introduce forces, and that raises a puzzle that we're going to analyse later in this session. My weight is 700 newtons. So, with what force do I pull on the rope? Forces are defined by and are central to Newton's laws of motion, which are this week's topic. Newton's laws are simple, but they're not obvious. So let's start by considering why Aristotle and many other smart people didn't discover them. Laws of physics are usually generalizations from experimental observation. In everyday experience, things tend to stop. Aristotle's generalization was that a force was required to keep things moving. But if you do this experiment, you'll feel the force that does the stopping. It's called friction. So a force, often friction, is responsible for stopping the motion. It's possible to reduce friction almost to zero with a layer of air on this air track, which makes the slider into a sort of hovercraft. See? Big accelerations at either end, but almost no acceleration in between. No horizontal force, so nearly constant velocity. 400 years ago, the Italian physicist Galileo studied motion using rolling balls because, in this case, friction doesn't much reduce the velocity. Galileo also noticed that a ball released from rest continues rolling until it reaches almost its original height. This is true for different shaped paths. So, he reasoned, if there were no forces to slow it down, the ball would roll forever. This was a revolutionary idea. For Aristotle, ordinary objects tended to stop. Their natural state was zero velocity. For Galileo, the natural state is zero acceleration, i.e. constant velocity. This is formalised in Newton's first law. If the total force on an object is zero, then it has zero acceleration. Equivalently, we could say, if the total force on it is zero, an object at rest remains at rest, and if the total force is zero, a moving object continues travelling in the same direction with the same speed. There's more about these laws on our resource sites. For now, remember, zero total force gives zero acceleration, and zero acceleration means that the velocity is constant. Now a question for you. If I roll a ball like this, what happens when it leaves the spiral? Come on, choose one. Commit yourself. Let's analyse it using Newton's law. While the ball is in the spiral, the wall is providing a horizontal force, and this horizontal force changes the direction of the velocity. A change in direction is a change in velocity, so inside the spiral, the ball is accelerating sideways. It's a bit like circular motion, where acceleration is at right angles to the velocity. Outside the spiral, there are no horizontal forces, so Newton's first law predicts no acceleration. It will travel at constant speed in a straight line. Well, let's put up some goalposts. Hey! Newton scores again, as he usually does. By the way, if you chose B, perhaps you're a billiard player. The ball is spinning anti-clockwise when it comes out of the spiral, and on the soft cloth of a billiard table, this spin would produce a sideways force on the deformed cloth. On this particular case, the surface is hard, and that effect's completely negligible. Conclusion. No force means no acceleration, which means constant velocity. The object doesn't remember what it was doing. To predict the future motion, the only things we need are the current velocity, the mass, and the total force acting. Now it's time for a quiz about the first law. Remember, if the total force on an object is zero, then it has zero acceleration. The reverse is also true. Zero acceleration means zero total force.